How to calibrate your laser using RE4. First, navigate to the calibration page by selecting the Setup Page button. Next, find the Device Local Page IP address and select your IP. Today, we will go over the DAC Chirurco calibration. The first step is to home the laser, so let's go ahead and do that now. Once the laser head has finished homing, the next step is to determine the lens's perfect focus to the base plate. This is typically pre-marked on the Z stage during our quality control process at the factory, with color-coded lines on your tower indicating the specific distance. In my jog controls, I am moving the tower to 0 millimeters. This sets the laser to be perfectly focused on the base plate. However, if you are calibrating your laser, this may not be the correct focus. You will need to manually determine the focus distance using the color-coded lines on your tower or by running a focus test to find the proper focus for the base plate. Now that we've set the desired focus distance, place a black aluminum business card under the laser dot. Run a focus test to ensure accuracy throughout the process. We can run the focus test by accessing our machine's current server. I am currently using RE4. This tab should already be open, so we can navigate back to it to run the test. Select the Laser Focus Test button. In this example, I'm using a 200-watt MOPA laser, so my settings may differ from yours. However, the goal is to run this test at low power to ensure accuracy. I've set the increment to 1 millimeter, so each time the laser pulses, the head moves by 1 millimeter through the focal range. This test can be run multiple times, and the increment can be adjusted to a smaller value for increased accuracy if needed. Once the job starts, the laser will move upward in 1 millimeter increments, creating a grid-like pattern. After the job is complete, we will examine the card under a microscope to gain a clearer understanding of the results. Let's take a look under the microscope. The laser engraves the squares in a snake-like pattern, separated by the 1 millimeter increment we set earlier. Initially, the engravings may appear blurry, but as the laser reaches squares A5 through G5, distinct straight lines become visible within the boxes, unlike the blended appearance of the others. What we're looking for is where the laser first starts engraving these lines and where it stops. In this case, my selection would be A5 and G5, and the system will automatically select the midpoint between these values. Alternatively, you can manually choose the box where the lines are most clearly defined. In this example, I would select D5. We can make our selections now and hit the Focus Selected Result button. Now that our laser is in perfect focus to the base plate, let's jump back over to our calibration page. Now, we are ready to start the Chirurco board overview. First, locate the Chirurco board that came with your machine. During this process, ensure the board is parallel to the base plate and perfectly flat. To achieve this, we recommend using Scotch Spray mount adhesive, which helps keep the paper flat, while also allowing for repositioning if needed. Once the Chirurco board is flat on the base plate and fully visible to the camera, we can go ahead and press Start. The machine is now generating the intrinsics for the camera capture. We can monitor the calibration stage in the top right corner. Now that the status has switched back to idle, we know this step is complete. Next, we need to ensure that all dots are visible and there are no blank spots. If you notice blank spots, there may be excessive light shining on the Chirurco board, which should be reduced or removed. Alternatively, the Charuco board itself may be damaged. Select Next, as we are now ready for step 2. In this step, we will engrave a small Charuco board to use for the camera's calibration. First, adjust the laser to match the height of your material if you have added any height to the workspace. We recommend using a black aluminum business card or a white sheet of paper with a black square printed on it. For step 2B, navigate to the Job Run page by selecting the button. Next, select the DAC Vector Charuco 4x4 lap file. Next, adjust the settings for your material. The goal is to achieve a bright white mark that the camera can detect, so you may need to run a few tests. Adjust the settings for the file labeled as 0000, ensuring it is the vector file. Once your adjustments are made, select the Set button. Then, run the perimeter check for the job, place your material, and you'll be ready to start the job. Once your material is placed, press Stop to stop the perimeter check. Then, close the lid and select Run. You can monitor the state of the laser in the top right corner. Now that we have a good engraving, without moving it at all, let's navigate back to the calibration page. Next, select Scan Charuco with Camera. We want to ensure that all 9 points are detected during this process. Open the results to view. As we can see, all 9 dots were detected. Now, go ahead and select Generate for step D and ensure all 9 dots are found. Select Next. The first step is to adjust the laser to focus on your test material. Since I'm using paper today, I'll leave the material height set to 0, as it adds virtually no thickness to the base plate. Let's go ahead and revisit the Job Run page, as we are now ready to engrave the full Charuco board. Select the DAC Vector Charuco lap file, and once again, adjust the settings for your material. The concept is the same as before. You may need to run tests to ensure you get the brightest mark possible from your laser. You might even need to run the job multiple times. Adjust the settings for the file labeled as 0000, ensuring it is the vector file. You can run the perimeter once again to ensure your engraving lands correctly on your material. Once your material is placed, select Stop. We want to ensure the material remains flat throughout the engraving. If needed, you can use some Scotch adhesive spray to mount your material to the base plate. Select Run when you are ready to start the job. We can now see that our engraving came out just fine. We are now ready to take this engraving to the scanner to scan the document. There are a few things to keep in mind when scanning your document. First, make sure your scanner can output at least 300 dpi. I will be scanning my document at 600 dpi. Additionally, ensure your scanner can output the scan in either JPG or PNG format. Then, go ahead and scan the document in the appropriate file format, as this particular file will be input into the system. Once you have your file, go ahead and import it into the system and select Scan Charuco Image. The goal is to scan as many corners as possible. If a few corners are missing, no worries. We can adjust those points in the next step. We can monitor the scan in the top right corner. Once the scan is complete, let's take a look at the result. We want to identify any corners that were not detected and then select the Edit SVG button to input the missing points. I've identified a total of 4 points that are missing, so let's go ahead and fix that now. Select the Edit SVG button. We can identify the missing points using both the scan and the DAC table to determine exactly which points are missing. Keep in mind that I uploaded my scan into the system sideways, so we need to account for that when searching for the missing points. Essentially, the top left corner of my scan corresponds to the top right corner in the DAC table. This may not be the same for you, so be sure to keep in mind the orientation in which you uploaded the scan. For example, if I click on a known point, it will display which point it actually is. Then, we can use this information to locate the corresponding point in the DAC table. I have located my reference point, which I am using to identify the missing dots. By analyzing the surrounding points, I can determine which ones need to be added. Since my scan is sideways, I have identified the 2 missing points located in the top left corner of my scan. We can select Auto Add Points, which will assign values to the missing dots. Then, we can locate the correct dots highlighted in yellow and move them to their corresponding positions. I will continue this process for my other 2 missing points. Once all your points have been added, select the Sync button, then proceed to download the refinement. Jump back to the calibration page and upload the refinement file. Be sure to store this file somewhere safe on your computer, as it is crucial if you ever need to redo the calibration or switch lenses. Once the refinement file is uploaded, select Generate New Calibration and ensure all points are found and correctly located. If any points are placed in the wrong DAC position, it could cause engraving issues, such as lines being engraved in odd directions. You have now successfully completed the calibration and are ready to start engraving. I hope this video helps, and once again, keep on making.